For more than a century, the gemstone world has followed one rule. The brighter the stone, the more valuable it becomes. That rule built the diamond industry. But some of the most intriguing gemstones on Earth don't sparkle at all. They don't form large crystals. They don't produce brilliant flashes of light. Instead, they are built from millions of microscopic crystals compressed together so tightly that the eye cannot see them. These are cryptocrystalline gemstones. And in recent years, collectors exploring portfolios beyond traditional diamonds have begun paying closer attention to them. Not because they replace diamonds, but because they reveal something diamonds rarely can. Patterns that look like landscapes, metallic fire hidden beneath mineral layers, and geological formations so unusual they shouldn't exist in gemstone form at all. Starting with a green stone once prized by kings, ranked 10th, Chrysoprase, color that quietly challenges the diamond mindset. For generations, the high-end gemstone world followed a very clear rule. The more a stone sparkled, the more valuable it seemed. Clarity, brilliance, and perfect crystal structure became the standards that defined luxury. Diamonds fit that philosophy perfectly. Sharp reflections, precise facets, and light bouncing in every direction. But Chrysoprase follows an entirely different idea of beauty. At first glance, the stone appears almost unusually calm. A smooth surface of luminous green, evenly spread across the gem, without the fractures or visible crystal lines that often appear in emerald. Instead of flashing brilliance, Chrysoprase produces something softer. A quiet internal glow that seems to emerge from deep inside the stone itself. And that effect comes from a structure most people never see. Unlike emerald or diamond, Chrysoprase is formed from cryptocrystalline quartz. Millions of microscopic crystals packed so tightly together that individual structures cannot be distinguished by the human eye. During formation, traces of nickel become distributed throughout this microstructure, creating the stone's distinctive apple green color. Because the crystals are so small and tightly fused, light doesn't reflect in sharp flashes. Instead, it scatters gently through the stone, producing the smooth, almost luminous color collectors recognize immediately. For centuries, that color carried extraordinary prestige. In 18th century Europe, Chrysoprase became one of the most admired ornamental stones in royal collections. Frederick the Great of Prussia famously used it to decorate parts of Sanssouci Palace, and jewelers across the continent carved the stone into rings, seals, and decorative objects long before diamonds came to dominate the modern jewelry market. Then tastes changed. During the 20th century, the gemstone industry shifted towards stones that maximize brilliance. Transparent crystals with dramatic sparkle became the centerpiece of luxury jewelry, while stones like Chrysoprase gradually faded from mainstream attention. But among collectors exploring gemstones beyond traditional diamond portfolios, something interesting has begun to happen. Chrysoprase represents a different philosophy of collecting. Its value isn't based on sharp flashes of light or crystal perfection. Instead, it lies in color purity, geological rarity, and the unmistakable character of its microcrystalline structure. When high-quality material appears, especially stones displaying deep, evenly saturated green, collectors recognize immediately that they are looking at something fundamentally different from emerald or diamond. Not a substitute, but an alternative aesthetic entirely. And that quiet shift towards stones with unique geological identity is exactly why cryptocrystalline gems are starting to attract renewed attention. Because the next stone on this list takes uniqueness even further. A gemstone marked by patterns so distinctive that every single piece becomes its own geological signature. Ranked 9th, Bloodstone, a gemstone. No two collectors own the same way. In the traditional gemstone world, perfection usually means consistency. Collectors search for stones that match. Identical color, identical clarity, identical brilliance. Diamonds built an entire industry around that idea. Standardized grading systems, calibrated stones, and predictable visual qualities became the language of luxury. Bloodstone breaks that rule almost immediately. At first glance, it appears as a deep green chalcedony, dense, opaque, and formed from the same cryptocrystalline quartz structure that defines many stones on this list. But scattered across that dark surface are vivid red inclusions, irregularly distributed like drops of pigment suspended inside the stone. Those marks are what make bloodstone unmistakable, and they also ensure something very unusual in gemstone collecting. No two pieces will ever look the same. Geologically, those red patterns form when iron-rich minerals become trapped within the chalcedony as it solidifies underground. Over time, oxidation transforms those mineral particles into small red flecks that appear embedded throughout the stone's surface. The process occurs randomly during formation, meaning each specimen develops its own pattern, sometimes subtle, sometimes dramatic. To mineral collectors, that randomness is part of the fascination, because unlike diamonds or many faceted gemstones, bloodstone cannot be standardized. Every piece carries its own visual identity. One stone might show only a few scattered red marks across dark green chalcedony. Another might reveal striking clusters of crimson inclusions spreading across the surface like abstract mineral artwork. This individuality is one of the reasons bloodstone held such a strong place in history. For more than 2,000 years, artisans carved it into seals, signet rings, and engraved amulets across the Mediterranean world. Roman soldiers were known to carry engraved bloodstones, believing the stones symbolized resilience and strength. Whether those beliefs were symbolic or practical mattered less than the stone's unmistakable appearance. Its pattern made it memorable. Today, that same characteristic resonates with a different type of collector. In a market where many gemstones are valued for flawless uniformity, stones like bloodstone appeal for the opposite reason: they guarantee uniqueness. Every piece feels personal, almost like a natural signature written by geological processes millions of years ago. And that idea is becoming increasingly attractive to collectors looking beyond traditional gemstone portfolios. Because cryptocrystalline stones often offer something diamonds rarely can: a sense that the earth itself created an artwork no cutter could ever reproduce. Yet visual identity alone is only the beginning of what these stones can do. Because the next gemstone on this list hides something far more dramatic. A stone that appears quiet and ordinary until the moment light reveals the fire hidden inside it. Ranked 8th, fire agate. When a stone reveals something diamonds never could. Most gemstones reveal their beauty immediately. A diamond sparkles the moment light hits its facets. Sapphire flashes with deep color as soon as it is turned toward a light source. The visual impact is instant and obvious. Fire agate behaves very differently. At first glance, the stone can appear almost unremarkable, a dark, rough surface of chalcedony that gives little indication of what lies beneath. In fact, many pieces of fire agate look dull when first discovered, their surface covered by layers of iron-rich mineral crust that hide the structure forming underneath. But when a skilled cutter begins to reveal those hidden layers, something extraordinary begins to appear. Metallic flashes, gold, copper, green, sometimes even violet tones moving across the surface of the stone as light changes angle. The effect looks almost like liquid fire trapped inside the gem, which is exactly how the stone earned its name. Geologically, the phenomenon is remarkably complex. Fire agate forms when thin layers of iron oxide deposit repeatedly along the surface of chalcedony as it develops inside volcanic rock cavities. Over long periods of time, these microscopic layers build up like delicate sheets of mineral film stacked one above another. When light enters the stone, it reflects and interferes between those layers, producing the shifting metallic colors visible on the surface. Unlike opal, where color appears through diffraction, the fire inside fire agate comes from structural interference created by mineral layering. And because those layers form unevenly inside volcanic cavities, every piece of fire agate develops a completely unique pattern of color and movement. Some stones reveal small flashes of metallic color across the surface. Others display large flowing waves of gold and green that seem to move as the stone is turned in light. For collectors, that unpredictability is part of the appeal. Unlike faceted gemstones that follow standardized cutting styles, fire agate must be shaped carefully to expose its internal color layers. The cutter cannot simply polish the stone into a symmetrical form. Instead, the stone is sculpted slowly, following the natural contours of the color hidden beneath the surface. Each finished piece becomes a collaboration between geology and craftsmanship. And that combination is precisely why some collectors find stones like fire agate so compelling. They reveal something that highly engineered brilliance cannot reproduce, a natural optical effect created entirely by geological processes. Yet even fire agate's hidden light is only one expression of what cryptocrystalline gemstones can create, because the next stone on this list doesn't reveal fire at all. Instead, it reveals something far stranger, patterns that look almost like entire landscapes preserved inside the stone itself. Ranked 7th, moss agate. When a gemstone becomes a landscape, some gemstones are admired for brilliance, others for clarity. Moss agate captures attention for an entirely different reason. It looks like nature itself was sealed inside stone. At first glance, moss agate appears as a translucent form of chalcedony, soft, cloudy quartz with a pale or slightly milky background. But inside that quiet surface, something remarkable begins to appear. Branching shapes, dark green mineral structures spreading through the stone like tiny forests, river valleys, or tangled roots frozen in place. In some specimens, the formations resemble drifting moss. In others, they look like entire miniature landscapes suspended beneath the surface. And that illusion is what gives the stone its name. Despite the appearance, moss agate does not actually contain organic material. The moss patterns are created when minerals such as manganese or iron become trapped inside the chalcedony during formation. As the silica-rich solution slowly solidifies underground, these mineral particles grow outward along microscopic fractures, forming delicate dendritic structures. Over time, the stone becomes a geological canvas. Every formation spreads differently, depending on pressure, temperature, and mineral concentration at the moment the stone develops. The result is something collectors find fascinating. Every moss agate looks completely unique. Some pieces display subtle branching patterns barely visible through the chalcedony. Others contain dramatic networks of dark green inclusions that stretch across the entire stone, creating the impression of forests suspended inside quartz. Because these formations occur naturally and unpredictably, no two stones can ever be identical. And that individuality is precisely what gives moss agate its quiet appeal among collectors. In a market dominated by calibrated gemstones and standardized brilliance, moss agate represents a very different philosophy of beauty. Instead of chasing perfect symmetry or flawless transparency, the stone invites the viewer to explore the unpredictable artistry created by geological processes over millions of years. A polished moss agate is less like a jewel and more like a small window into Earth's natural design. Turn the stone slightly, and the patterns shift in depth and complexity. One angle might reveal a cluster of branching mineral structures resembling trees along a hillside. Another might show thin mineral veins drifting like clouds across the interior. Collectors often describe the experience of examining moss agate as similar to studying landscape paintings, except the artist in this case is geology itself. But even stones that resemble landscapes are only part of the story cryptocrystalline gemstones can tell, because the next stone on this list reveals a very different kind of beauty, one that doesn't rely on patterns or brilliance at all, but on a subtle glow that modern jewelry designers have begun quietly rediscovering. Ranked 6th, blue chalcedony, when glow replaces sparkle. For much of modern jewelry history, brilliance defined luxury. The brightest stones, diamonds, sapphires, and other transparent crystals, dominated high-end design because they reflected light sharply and dramatically. Facets were cut to maximize sparkle, and the visual language of luxury became closely tied to brilliance. Blue chalcedony follows a completely different philosophy. Instead of reflecting light in flashes, the stone appears to glow softly from within. At first glance, blue chalcedony seems understated. Its color is gentle, a calm, misty blue that often resembles the sky just before sunrise or the soft haze over distant water. The surface is smooth, sometimes polished into cabochons rather than faceted stones, emphasizing the stone's internal character rather than surface reflections. But the visual effect becomes clearer the longer the stone is observed. Light does not bounce sharply off blue chalcedony the way it does from crystalline gemstones. Instead, it passes through the stone and scatters across its microcrystalline quartz structure, diffusing evenly throughout the interior. This scattering effect creates a luminous appearance that many collectors describe as a quiet glow rather than brilliance. That subtle optical quality is precisely what has begun attracting attention in modern jewelry design. Over the past 2 decades, some high-end designers have gradually moved toward gemstones that emphasize color depth and surface texture rather than traditional sparkle. In this design language, stones like blue chalcedony offer something refreshing, a calm visual presence that contrasts sharply with the intense brilliance of diamonds. Rather than dominating the eye, the stone draws attention slowly. Its color appears almost atmospheric, shifting gently depending on lighting conditions. Under natural light, the stone can appear soft and translucent. Under stronger illumination, the internal glow becomes more pronounced, revealing subtle layers and depth within the chalcedony. This aesthetic has led many designers to incorporate blue chalcedony into modern luxury jewelry collections, often pairing it with gold or minimalist settings that allow the stone's natural color to remain the central focus. For collectors exploring gemstones beyond traditional diamond-centered portfolios, this design shift introduces a different way of appreciating value. Instead of brilliance and clarity alone, stones like blue chalcedony highlight color atmosphere, geological formation, and understated visual presence. It represents a quieter form of luxury, one that rewards careful observation rather than immediate visual impact. Yet even the calm glow of blue chalcedony is only one expression of what cryptocrystalline gemstones can achieve, because the next stone on this list reveals something even more precise. Patterns formed so perfectly by geological processes that they appear almost engineered rather than natural. Ranked 5th, Botswana agate, when nature creates perfect structure. In most gemstones, beauty comes from color or brilliance. Botswana agate introduces something else entirely: precision. At first glance, the stone may seem understated. Soft gray, pale pink, or warm beige tones layered gently across the surface. But look closer, and the true character of Botswana agate begins to emerge. Thin, perfectly curved bands flowing across the stone. Layer after layer, sometimes dozens, sometimes hundreds, each one tracing the contours of the cavity where the mineral slowly formed millions of years ago. These bands are not decorative patterns carved by a cutter. They are the direct result of a geological process unfolding deep inside ancient volcanic rock. Botswana agate forms when silica-rich fluids gradually fill hollow spaces inside cooling lava. As the mineral solution deposits microscopic quartz crystals along the inner walls of those cavities, it does so in repeated stages. Each stage leaves behind a thin layer of chalcedony before the next mineral pulse arrives. Over long stretches of geological time, these cycles build the banded structures that define the stone. What makes Botswana agate especially remarkable is the consistency of those layers. In some specimens, the bands curve so smoothly and evenly that they appear almost engineered. Concentric rings follow the shape of the volcanic cavity like delicate contour lines on a geological map. Under magnification, the bands reveal subtle variations in color, pale grays transitioning into soft pinks or deeper browns as trace minerals influence each stage of formation. For collectors, this precision holds a special fascination. While many gemstones are prized for flawless transparency or dramatic optical effects, Botswana agate offers a different form of visual order, one created entirely by natural mineral processes repeating themselves over immense periods of time. Each band represents a separate moment in the stone's geological history, a layer formed, then sealed, then followed by another. The result is a gemstone that records its own formation in visible structure. And because every volcanic cavity forms under slightly different conditions, no two Botswana agates ever display exactly the same pattern. Some stones show tight concentric rings like ripples in water. Others reveal long flowing layers that sweep across the surface in elegant arcs. This natural architecture is part of what draws collectors towards stones like Botswana agate. It reflects a type of beauty that diamonds rarely reveal: the ability to see geological time preserved inside a gemstone. Yet even these elegant structures are only one way cryptocrystalline gemstones capture attention, because the next stone on this list takes a completely different approach. a gemstone defined not by pattern or glow, but by something far more striking, the absence of light itself. Ranked fourth, black chalcedony, a gemstone defined by darkness. Most gemstones are designed to interact with light. Diamonds scatter it into flashes, sapphires bend it into deep pools of color, opals fracture it into shifting rainbows. Black chalcedony does something very different. It almost absorbs light completely. At first glance, the stone can appear deceptively simple, a smooth surface of deep, uninterrupted black. No sparkle, no visible internal structure, just a quiet, almost mirror-like darkness that seems to pull the eye inward rather than reflect light outward. Yet that simplicity is precisely what gives black chalcedony its striking presence. Like many stones on this list, it forms from cryptocrystalline quartz, a dense mass of microscopic crystals packed together so tightly that individual crystal faces never develop. Instead of producing transparency or sharp reflections, this structure creates a smooth, uniform surface capable of taking an exceptionally high polish. When polished, the stone develops a subtle reflective sheen, not the brilliance of faceted gems, but a deep, liquid-like surface that appears almost infinite in depth. That visual quality has made black chalcedony increasingly appealing within a design movement that values restraint over spectacle. In recent years, high-end jewelry designers have shown growing interest in stones that emphasize contrast and minimalism. Rather than relying solely on brilliance, these designs use dark gemstones to frame precious metals or lighter stones, creating dramatic visual balance. Black chalcedony fits naturally into that philosophy. Its dark surface provides a powerful counterpoint to gold, platinum, or even diamonds themselves. When set alongside brighter gemstones, the stone acts almost like negative space in visual design, allowing other elements to stand out more clearly. But the appeal of black chalcedony is not limited to modern aesthetics. Throughout history, dark chalcedony varieties were often used for signet rings and carved seals because of their durability and smooth surface. The fine-grained microcrystalline structure allowed artisans to engrave precise designs that remained crisp even after years of wear. This combination of durability, polish, and visual depth has helped the stone maintain a quiet presence in jewelry for centuries. Today, collectors exploring gemstones beyond traditional diamond-centered portfolios sometimes appreciate stones like black chalcedony for exactly that understated character. It doesn't compete with brilliance. Instead, it offers something rarer in modern luxury design, the elegance of simplicity. Yet even the deep stillness of black chalcedony is only one expression of what cryptocrystalline gemstones can create, because the next stone on this list reveals something far more intricate, patterns so complex that they resemble entire landscapes formed naturally inside the stone itself. Ranked third, dendritic agate, when minerals begin to resemble nature. Most gemstones reveal their beauty through color or light. Dendritic agate reveals something far more unexpected. It reveals patterns that look alive. At first glance, the stone appears as a pale or translucent chalcedony, soft white, gray, or faintly cloudy quartz that might seem unremarkable on its own. But beneath that quiet surface, dark branching structures begin to spread across the interior of the stone. Thin lines divide and branch outward. Some resemble trees reaching across a winter landscape. Others look like lightning frozen in time. And occasionally, entire formations appear that look astonishingly like forests stretching across a distant horizon. These patterns are known as dendrites, a word derived from the Greek term for tree. But despite their organic appearance, they are entirely mineral. Dendritic agate forms when microscopic fractures develop within chalcedony as it solidifies underground. Mineral-rich fluids carrying elements such as manganese or iron seep into these tiny channels. As the minerals crystallize, they grow outward along branching paths, creating the intricate structures visible inside the stone. Over time, the stone becomes a canvas for these mineral formations. Unlike banded agates that develop in predictable layers, dendritic agates grow in far more chaotic patterns. The minerals follow pathways dictated by pressure, temperature, and microscopic cracks in the surrounding quartz matrix. The result is something no cutter or jeweler could ever replicate deliberately. Every dendritic agate becomes a geological composition unique to that single moment of formation. Some stones contain only a few delicate branches drifting across pale chalcedony. Others develop dense networks of dendrites that spread across the entire stone, forming patterns so complex they resemble aerial views of river systems or mountain forests. Collectors often find themselves studying these stones for long periods, tracing the branching structures the same way someone might examine a landscape painting, because that is precisely what the stone begins to resemble. Not a crystal, but a scene captured in mineral form. This visual storytelling is one of the reasons dendritic agate has long appealed to collectors and artisans alike. When cut into cabochons or polished slabs, the stone often appears less like jewelry and more like a natural work of art, a small geological world preserved beneath the surface. In a gemstone market often defined by clarity grades and standardized brilliance, dendritic agate offers something completely different. A reminder that some of the most fascinating structures on Earth are not symmetrical or predictable. They are the result of geology improvising over millions of years. Yet even these intricate mineral landscapes are not the most historically significant cryptocrystalline stones collectors have valued. Because the next gemstone on this list played a far more direct role in shaping the history of jewelry itself. A stone that once carried the marks of kings, nobles, and entire civilizations. Ranked second, natural banded onyx, the gemstone that carved power into stone. Long before modern gemstone markets existed, certain stones held value for a very different reason. They could record identity. Natural banded onyx became one of the most important gemstones in that tradition. At first glance, onyx appears simple, smooth layers of black and white chalcedony arranged in parallel bands across the stone. But those layers reveal something remarkable about how the gem forms. Like other cryptocrystalline stones, onyx develops when silica-rich solutions deposit microscopic quartz crystals inside cavities within volcanic rock. Over time, these deposits occur in rhythmic cycles, each layer forming with slightly different mineral content than the one before it. The result is a gemstone composed of perfectly parallel layers of chalcedony, stacked one above another like geological pages recording the stone's formation. For ancient artisans, this structure presented an extraordinary opportunity because each layer carried a different color. A skilled carver could cut through the stone carefully, removing one layer while leaving another intact. This allowed artists to create images where figures, symbols, or portraits emerged in contrasting colors directly from the stone itself. These carvings became known as cameos. Throughout the Roman Empire and later European courts, cameos carved from banded onyx became powerful symbols of identity and authority. Nobles wore them as signet rings, pressing the carved image into wax seals to authenticate documents. Kings commissioned elaborate cameos depicting rulers, mythological scenes, or imperial victories. Unlike faceted gemstones designed to scatter light, onyx served a completely different purpose. It carried information. Every carved surface preserved the mark of the artisan who shaped it and the identity of the person who owned it. Some of the most famous cameos created during the Roman period still survive today in museum collections, their layered structures revealing astonishing detail even after thousands of years. The durability of chalcedony made this possible. Because cryptocrystalline quartz is extremely dense and fine-grained, the stone allows for engraving far more precise than most crystalline gemstones can support. Once carved, those details remain sharp for centuries. For collectors today, natural banded onyx represents more than just a decorative stone. It reflects a chapter of gemstone history where value was defined not by brilliance or rarity alone, but by the role the stone played in human culture. It was a gemstone that shaped communication, authority, and craftsmanship long before modern jewelry trends began emphasizing sparkle. And that historical significance continues to draw interest among collectors, exploring stones beyond the traditional diamond narrative. Yet even a gemstone that carried the symbols of emperors is not the most unusual formation on this list. Because the final stone represents something far more surprising, a gemstone that, according to its own mineral chemistry, should never have formed as a stable gem at all. In first place, Chrysocolla chalcedony, a gemstone that shouldn't exist in stable form. Some gemstones earn their reputation through brilliance, others through rarity. But the final stone on this list stands apart for a far stranger reason. According to its own mineral chemistry, it shouldn't exist in this form at all. The story begins with Chrysocolla, a copper-rich mineral long known for its striking shades of blue and green. In its natural state, Chrysocolla often appears in soft, earthy masses within copper deposits, displaying colors that range from deep turquoise to electric teal. Visually, it can be breathtaking, but mineralogically, it carries a problem. Pure Chrysocolla is relatively soft and unstable compared with most gemstones. On its own, the mineral rarely forms material durable enough for long-term jewelry use. Historically, this meant Chrysocolla was admired more as a mineral specimen than as a true gemstone. Yet under rare geological conditions, something unusual can happen. During the formation of certain copper deposits, silica-rich fluids infiltrate the Chrysocolla structure, gradually binding the copper mineral within a dense microcrystalline quartz matrix. As this process unfolds, the surrounding chalcedony stabilizes the Chrysocolla, preserving its color while dramatically increasing the stone's durability. The result is Chrysocolla chalcedony, a gemstone where vibrant copper-based color becomes permanently locked inside cryptocrystalline quartz. The visual effect can be remarkable. Deep blues swirl into turquoise greens, sometimes flowing across the stone in layered patterns that resemble aerial views of oceans meeting tropical coastlines. In other specimens, the color spreads more evenly, creating luminous surfaces that appear almost liquid beneath a polished finish. And because the stabilization occurs naturally within the stone itself, rather than through artificial treatment, each specimen develops its own internal landscape. No two pieces ever look exactly the same. For collectors exploring gemstones beyond traditional diamond-centered portfolios, formations like Chrysocolla chalcedony hold a special fascination. They represent moments where geological processes intersect in unexpected ways, producing materials that exist only under very specific conditions. Copper minerals alone would have remained too soft. Quartz alone would have produced a colorless stone, but together, under the right pressures and chemistry deep within the earth, they form something entirely different. A gemstone combining structural stability with some of the most vivid natural blues and greens found in the mineral world. It is a reminder that the story of gemstones does not always follow the familiar path of brilliance and transparency. Sometimes the most intriguing stones are the ones created when geology bends its own rules. And cryptocrystalline gemstones, with their hidden structures and unpredictable formations, reveal just how many of those rules remain undiscovered. For more than a century, gemstones have been judged by brilliance. The brighter the stone, the more valuable it was believed to be. But cryptocrystalline gemstones reveal a different side of the Earth's geology, beauty that forms in patterns instead of crystals, in layers instead of facets, and sometimes in structures so unusual they seem almost impossible. They may never replace diamonds, but they remind collectors of something important. Some of the most fascinating gemstones on Earth don't sparkle the most. They tell the most interesting stories. So here's a question worth asking. Which of these cryptocrystalline gems surprised you the most? And would you add one to a collection beyond diamonds?